This is Barry Molitor's movie explaining the differences between Jacobi, Gauss-Seidel, and SOR methods of iteration. Start with Jacobi. You start out your Jacobi iteration with a guess for your variables x, 1, 2, 3, and so on. Insert your guess and continue recalculating. So for instance, if you've got 3 equations, 3 unknowns, x, 1, 2, and 3, rewrite those equations into x, 1, 2, and 3. You can then create a table here with your, say, initial guesses of 0, use 1, whatever you want. So you would calculate your x1 based on your initial guess of 0, calculate x2 based on your initial guess of 0, calculate x3, initial guess of 0, so on and so forth. And then that is your Jacobi. For the Gauss-Seidel method, it's almost identical. Except that the Gauss-Seidel method uses latest values. So in this case, you would calculate your x1 based on your initial guess, and then when you calculate your x2, instead of using your initial guess of 0 or whatever for x1, you would use the value you just calculated for x1. Similar when you get to x3, you use the values you previously calculated for x2 and x1 instead of your initial guesses. And then that's better than Jacobi because you get an answer with fewer iterations. Now the SOR, or successive over-relaxation method, this works with the Jacobi or Gauss-Seidel method and employs basically a mathematical adjustment, which is kind of like a weighted average. And its key difference is faster convergence. And what you do here is you imply or apply a W, which is a relaxation factor. And here we have the Gauss-Seidel method written out. And what we're doing here is we're taking our W and 1 minus W and adjusting for our relaxation parameter. Our previous number, or previous calculation, plus W times our Gauss-Seidel iteration in this case. And if we use the relaxation parameter of 1, this goes to 0, this term, and we're just getting Gauss-Seidel. And if we use a relaxation of between 0 and 1, where you can see that we're placing more weight on this term than our Gauss-Seidel term. So what we want is a relaxation parameter between 1 and 2, which places more weight on our Gauss-Seidel term. And actually this will turn negative, and this underweights this term. And we iterate in that way, and we get faster convergence than just Jacobi or Gauss-Seidel.